You are welcome once again to this channel, that is Sanity Media. Today is your teacher, Sir Emmanuel Amasanity, taking you to this lesson. Today we are looking at altitude and temperature calculation. Sometimes, as geography students, we are sometimes charged or asked to calculate temperature in our exams. Now, this presentation explores how temperature changes with altitude using the concept of what we know as environmental lapse rate. Understanding this principle is crucial for students studying geography and atmospheric science. So, as it explains why higher elevations are cooler and how this affects weather patterns and how it also affects climate. We will cover key definitions of and formulas and sample calculations to build a comprehensive understanding of the topic as a whole. So we will start with what we have today to discuss, that is temperature. Now, we know that from the atmosphere level, say that from the troposphere, they have stratosphere, thermosphere, and the rest. Say that the higher you go up, the cooler it becomes. So what causes that? Let's look at the reason that leads to that. Temperature measures the degree of hotness or coolness of place or subject or object. Typically, we measure it in degrees Celsius. Now, imbalance in weather and climate, it is a major factor influencing a region's climate, that is temperature, driving weather phenomena such as rainfall, wind, and atmospheric stability. All of them influence the climate of a place or temperature of a place. Now, what is say environmental lapse rate? When you say environmental lapse rate, what is it about? When you say environmental lapse rate, let's look at environmental lapse rate. You say that the environmental lapse rate is the average rate at which air temperature drops as altitude increases. So average temperature drops as one goes up or one moves to the other or move to next level. That is what we want to say here. So the average temperature drops whilst altitude also increases. And this rate characterized the cooling of air with height in the lower atmosphere, not in the higher part, in the lower atmosphere, that is the cooler or the cooling of air with height in the lower atmosphere. That is environmental lapse rate. That is where you say that the higher you go, the cooler it becomes. The higher you go, the cooler it becomes. Then temperature decreased by 6.5. It decreased by 6.5 degrees Celsius. 6.5 degrees Celsius. 6.5 degrees Celsius per every 100 meters ascent or rise up. So every level beer temperature goes up or the height rise up for 100 meters, temperature also falls 6.5 degrees, which is equivalent to 0.65 degrees Celsius per 100 meters or ascent. So you should know that, don't forget that also. Now, how to calculate temperature changes with altitude? Step one, what you must know and do is that you must measure the height differences. You must measure the height differences. Then how do you do so? Determine the vertical distance in meters over which temperature changes. So, from the peak of a mountain to its base on the floor, you must know the height of the temperature. Then what do you do again? You apply the lapse rate formula, where we say that every 100 meters ascended, 1,000 meters ascended, there's a fall of 6.5 degrees Celsius. So you apply the lapse rate formula to your answer that you're going to get, then you get it. That is, you divide the height by 1,000 and multiply by 6.5. Then you get the fall of temperature. You get the fall of temperature. Then that one says that subtract temperature change when ascending, add it when you are descending. So when you are going up, temperature reduces. But if you are on top of a mountain and you are coming downwards, the temperature also increase. So temperature is more higher at the lower elevation than as you climb or you go up to the next level in the atmosphere. That is what you should know. Temperature falls at the lower base, but it increases at the ascent part or at the top of a mountain. It increases. That is environmental lapse rate. Now let's look at the following examples. Now looking at the diagram I have at my left hand side here, you can see that I have this here. If this is the base of the mountain, you could see that the base is here and you have the top here. Now we are going to look at the fall of temperature with this example. Now the question says that you should find the temperature on the mountain A, temperature of mountain A, temperature of mountain A. Now, base temperature is 40 degrees as given in the question. The temperature at the base, here, it says that is just 40 degrees Celsius. Here is 40 degrees. 40 degrees. Then we are also saying that the mountain height is 400 meters. So from the base to the top of the mountain measures 4,000 meters. What are you going to do? Calculate temperature change. That is, you divide height. You divide the height. You divide the height by 100 meters or by 1,000 meters, which will give you 4. Then multiply it by the lapse rate, that is 6.5 degrees Celsius, giving you a value of 26 degrees Celsius. Now find temperature at the summit. So that's the difference. The difference has given you 20. So moving from the base to the top or to the summit, what you have to do is that you must subtract the 26 degrees Celsius from the one given to you at the base. So that the temperature at the top of the mountain is going to be 40 degrees Celsius minus what is 26 degrees Celsius, giving you 14 degrees Celsius. This means that at the top of this mountain that we have here, at the top here, the temperature here is 14 degrees Celsius. So you must first find the temperature differences, then you multiply by the lapse rate formula. Then when you do that, if you get the answer that you get, you just subtract it from the base one given to you. Subtract from the base one given to you. Thank you. So that is example 1 as I was saying. That is example 1 as I was saying. Now let's look at our work example number 2. So that is example 1. We'll look at example 2. Now example 2 says that temperature at the top of a mountain is 5,000 meters. That is the problem. The base temperature is 29 degrees Celsius, while the height in meters says that it is 5,000 meters altitude. So we should work out for the temperature at the top. If the base temperature is 29 degrees Celsius, ought to be at the top. Since we said that for every 100 or 1,000 meters ascent, there is a fall of 6.5 degrees Celsius. So if the base is 29 degrees Celsius and the top height is 5,000, what is going to be the temperature at the top, since it's going to decrease 5 times? 5 times in relation to the formula for, or the value of lapse rate, which is 6.5 degrees Celsius. Now height divided by 100,000 going to be 500,000 divided by 100. Let me circle it there for you so that you see. So we have this. This is what I'm talking about here. Yes. So you divide 5,000 by 100,000, which will give you 5. That's the difference. The height difference is 500 or 5, sorry. Temperature decreases. So what are you going to do? You multiply the 5 by 6.5, which is the lapse rate formula or value. So when you multiply 5 by 6.5 degrees Celsius, it's going to give you 22.5 degrees Celsius. But because we are saying that the more you go to the height or to the top of the mountain, the temperature also falls or decreases. We are going to subtract 32.5 degrees Celsius from the one given to us at the base, which is the 29 degrees Celsius. So here we subtract 32.5 degrees Celsius from 29 degrees Celsius here, which will give us negative 3.5, so negative 3.5 degrees Celsius as our final answer. Negative 3.5 degrees Celsius as our final answer, Good. So that is that example that we look at. Then the third example for today says that finding base temperature. This one, they have given you the temperature at the top and you are looking for the one at the base. So what you're going to do is you have to go with the same formula. You must find the difference. You divide the height by 100,000. Then you multiply by 6.5. Because now you are at the top, you are going to add what you're going to get because you are coming down. And the more you are coming down from the mountain top to the base, temperature increase. But when you are at the base and you are going upwards, the last phrase formula says that temperature falls, which is 6.5. So what are you going to do? Identify the known values. So here, with this example 3, we are at the top and we are looking for the temperature at the base. So with this example, it says that finding base temperature at the top is 16 degrees Celsius on the mountain, and the mountain height is 6,000 meters. So if at the top is 16 degrees Celsius, you're going to look at the temperature that will be at the base. Here is going to be increased. It's going to be more than the one at the top. So you find the temperature change. So 6,000 divided by, so it's not 100, this is 100,000. Not 100, this is 100,000. By 100,000 will give us 6. Will give us what? 6. So multiply 6 by 6.5 degrees Celsius, which will give the temperature different. That is 39 degrees Celsius. 39 degrees Celsius. 39 degrees Celsius. Now calculate temperature at base. Move downward. So what you have to do is you must add the temperature difference to the one given to you at the top, because as you're coming down, temperature is going to increase. But in case you were looking for the one at the top rather, then temperature at the top before. So here we are going to add the 39 degrees Celsius to the one given to us at the top, which is 16 degrees Celsius. So now we're going to have 16 degrees Celsius plus what is 39 degrees Celsius, giving us 55 degrees Celsius. 55 degrees Celsius. So take note of this. This example demonstrates how temperature increase as you descend to the foot of the mountain. So my followers and learners, you should take note of this. Now let's look at the rules or the formula that you must put in mind. Ascent, meaning when you are going up. Ascent means you are going up. Some small tips. Temperature decrease, you subtract temperature drop from starting temperature. That is 6.5. And what to calculate for? You subtract it if you're looking for the one at the top. But if you're looking for the one at the down, the base, it reduces. So what you do is that you add the temperature rise to starting temperature. So in case they have given you the one at the top of the mountain, and you're looking for the one at the base, what you must do is that when you find the temperature finish, you add it to the one given to you at the top to get that of the base one. Then the last phrase is 6.5 degrees Celsius temperature change per 100 or 1,000 meters unless otherwise instructed. So please, let's try to put our best in that. So you end the lesson here for today for joining. Try to like, share, and subscribe. Thank you very much.